In this video, we're going to talk about Pythagorean triples and just kind of what that means with right triangles and how we can determine if some things are right triangles. This is page 111 if you're in my class and you're keeping up with your binders. Just some vocabulary word, a Pythagorean triple is any three integers that satisfy a squared plus b squared equals c squared. So if I've got a squared plus b squared equals c squared, and a, b, and c are integers, then those three, a, b, and c, are Pythagorean triples. It's very important that you remember for today's lesson that the hypotenuse is the longest side of a right triangle, and the legs are the shorter sides. Pythagorean theorem works both ways. I've got works both ways and some quotations there. Once you get to geometry, you'll probably learn the fancier word for this. Essentially what we're doing though is we're going to start out with, if we know that a, b, and c form a right triangle, if I know I've got a right triangle, then I know a squared plus b squared equals c squared is a true equation. That's what we've learned, but it works both ways. So if a squared plus b squared equals c squared is true, then I know a, b, and c make a right triangle. I'm saying it works both ways because in the first statement, we start with a, b, and c making a right triangle. And then we say, if I've got this right triangle with side lengths a, b, and c, then I know this equation is true. But we can go backwards. I can start out with that equation, and I can say if a squared plus b squared equals c squared is true, then I know I've got this right triangle with lengths a, b, and c as the sides. And that's what we're doing today. Looking at an example, the first two examples are really just picking apart the triangle and determining whether or not we have a Pythagorean triple. So here I've got a right triangle and the lengths are 5, 12, and 13. The legs have to be shorter, so the legs are going to be 5 and 12 because the hypotenuse is the longest side and the longest length here is 13. Now I know this is a right triangle. I want to know, is this a Pythagorean triple? A Pythagorean triple is just any three integers that satisfy a squared plus b squared equals c squared. So if I know that these lengths form a right triangle, I know I've got a right triangle, so a squared plus b squared equals c squared is true. And these are all integers. Since those are all integers and it forms a right triangle, these are a Pythagorean triple. So I'm going to say 5, 12, and 13 are integers, because the problem told me that they were the lengths of a right triangle. So I feel like that's probably understood. Looking at the second example, now we have a right triangle and the lengths are 9/10, 1 2/10, and 1 5/10, 0.9, 1.2, and 1.5. So the hypotenuse is going to be the longest side. The largest number here, or the longest length, is 1.5. The shorter lengths are 0.9 and 1.2, 9/10 and 1 2/10. Now I know these form a right triangle, except these aren't integers. Since they're not integers, I can't have a Pythagorean triple. So even though those three lengths form a right triangle, they're not a Pythagorean triple because they're not integers. Looking at this example here, I've got a triangle has sides with lengths 21 miles, 28 miles, and 35 miles. I want to know, is this a right triangle? So now I'm going backwards. I want to know if this is a right triangle. Normally we have a right triangle and we have a missing side length. So I know that if the equation a squared plus b squared equals c squared is true, then a, b, and c will make a right triangle. So I need to pretend which ones are a, b, and c, and I'm going to hope to get a true equation if I want a right triangle. So 21 and 28 are both shorter than 35. So I'm going to say a can be 21, b can be 28, and c, the hypotenuse, has to be the longest, so I'll say that's 35. So now I just want to know, does that equation a squared plus b squared equals c squared, is that true? So a squared plus b squared equals c squared. Instead of a squared, I'll write 21 squared. Instead of b squared, I'll write 28 squared. And instead of c squared, I'll write 35 squared. This is where my calculator is probably going to come in really handy, especially if you haven't memorized your squares. Okay, we've got 21, and remember you can hit the x squared button to get the square sign to pop up. So 21 squared plus 28 squared. Another way you can get the square button is by hitting the caret key. That will type in an exponent. So 21 squared plus 28 to the second power will get us 1,225. And on the right side, we've got 35 squared. And 35 squared is 1,225. Those are both equal to each other, which means this equation is true. And remember, if I've got a true equation, then a, b, and c are going to form a right triangle. That means, yes, 21, 28, and 35 will form a right-angled triangle. Looking here, I want you guys to think about, in this situation where a triangle has side lengths of 4 meters, 8 meters, and 12 meters, what would the hypotenuse be? You need A, B, and C. C has to be the longest length of the hypotenuse. 4 and 8 are both smaller than 12. So 12 will be the hypotenuse. That means it doesn't matter which one is which. I can say B is 4 and A is 8. Those are just both legs. To determine if this is a right triangle, I need to know, is this a true equation? A squared plus b squared equals c squared. Does Pythagorean theorem hold true for these lengths a, b, and c? So we'll look at a to the second power plus b squared equals c squared. Instead of a squared, I can write 8 squared. Instead of b squared, I can write 4 squared. And instead of c squared, I can write 12 squared. 8 squared is 64. 4 squared is 16, and 12 squared is 144. I've kind of run out of room, so I'm just going to move my work over here. 64 plus 16 is 80, and 80 does not equal 144. So this is not a true equation. Since A, B, and C, with A being 8, B being 4, and C being 12, won't make a squared plus b squared equals c squared true, this is not a right triangle. No, 4, 8, and 12 will not form a right triangle. Looking at the next two, it's a little more visually appealing because we actually see a triangle. And I just want to know, is this a right angle? To determine if that's a right angle, I need to know what would A be, what would B be, and what would C be. 21 is the longest length, and 16 and 12 are shorter, so 21 would have to be C, and it doesn't matter which lengths I call A and B. We're going to use A, B, and C. We're going to plug that into a squared plus b squared equals c squared. And if the equation is true, this is a right triangle. If this equation is false, it is not. If Pythagorean theorem is true, I get a right triangle, because Pythagorean theorem only works for right triangles. So we'll use a squared plus b squared equals c squared. A is 16, so a squared is 16 squared. B is 12, so b squared is 12 squared. And c is 21, so c squared is 21 squared. 16 squared is 256. 12 squared is 144. You guys probably haven't memorized this, so this is where you'll take out your calculator. Words are hard today. 21 squared, 441. When you add 256 and 144, you get 60, 300, 400. And 400 does not equal 441. So this is a false equation. Since Pythagorean theorem was false for these three lengths, this is not a right triangle. Now let's look on the next example that's kind of similar to that. I need to know if this were to be a right triangle, the hypotenuse would be the longest side. The longest side is 20. So 12 and 16 would be our legs again. So now we've got A equals, I'll keep that 16, B is 12, and C is 20. So when I plug in Pythagorean theorem, a squared plus b squared equals c squared. That's the equation for Pythagorean theorem. A is 16, so we'll have 16 squared, plus b is 12, 12 squared, should equal c is 20, 20 squared. 16 squared is 256, plus 12 squared is 144, equals 20 squared, 400. 256 plus 144 is 400, and 400 does equal 400. So this is true. Pythagorean theorem was true for these three side lengths. So this is a right triangle, because Pythagorean theorem only works in right triangles. The last two problems just want me to use Pythagorean theorem to determine if it is possible to have a right triangle with lengths 8, 12, and 15. This should have said right triangle with those side lengths. Okay. My options are 8, 12, and 15 for A, B, and C. I know that C has to be the longest one. The longest side length here is 15. I'll say B is 8 and A is 12. So using Pythagorean theorem, a squared plus b squared equals c squared, I want to see if this is true or false. If it's true, I'll have a right triangle. If it's false, I won't have a right triangle using these side lengths. Instead of A squared, I can say 12 squared. Instead of b squared, I can say 8 squared. And instead of c squared, I can say 15 squared. 12 squared is 144. 8 squared is 64. And 15 squared is 225. 144 plus 64 is 208. 208 does not equal 225. This is false. Since Pythagorean theorem was false for these three side lengths, this is not a right triangle. Now looking here, I want to know, do 7, 13, and 15 make a right triangle? If they make a right triangle, I know A squared plus B squared equals C squared will be true. Looking at my side lengths, the longest one has to be the hypotenuse. The longest side length there is 15. I'll say that A is 7 and B is 13. A squared is now 7 squared plus B squared is 13 squared equals C squared or 15 squared. 7 squared is 49. 13 squared is 169. 15 squared is 225. That's 188, 228. So now I've got 228 equals 225. That's not true, which means a squared plus b squared equals c squared. Pythagorean theorem was not true for these three side lengths, so these three side lengths do not form a right triangle. As always, if you have questions about the content in this video, please don't hesitate to send me a Schoology message, shoot me an email, or drop a comment on the video, and I'll get back to you as soon as I can. This was Pythagorean triples and using Pythagorean theorem to determine if a triangle was a right triangle or not.